Okay, so this last page, this is a little bit trickier, and I really want us to be careful, is this graph, when we read this question, it's the graph of the derivative. So this is no longer h of x, this is now h prime of x. This is the derivative already. So this is a little bit of a harder process, but we can draw the graph of the derivative. So h of x is some other graph. We don't know what it looks like. It might look like this, but it's not this. This is a different graph, so we want to be careful about this. So this is our derivative graph already. So if we wanted to know where is h of x, again, we don't have this graph, but where is it increasing, right? What did we know about h prime? Because that's what we have. We have h prime. So we know that when h prime of x is positive, right, greater than 0, that our graph is increasing. So where is this graph positive? It's positive between -2 and 1. These are positive values, okay? We're not looking at, a lot of students mess this up, and they look for, oh, where's the graph increasing? And they say it's from -infinity to -1. That would have been for h of x, but we don't have h of x, we have h prime of x. So it's only the positive sections. It doesn't matter if it's going up or down. Right here, h prime of x is going down, but that doesn't matter because we only want the positive values, right? Because we have the derivative. So it's a little bit trickier, it's a little bit different. So we're going to say h of x, the original, is increasing for -2 to 1, union 3 to infinity, because h prime of x is positive there. It's greater than 0. So the flip side of this would be the negative parts, right? So when it's decreasing, what do we know about h prime? We know that h prime is less than 0. Why are we doing this? Because we have the derivative graph. We don't have the original graph anymore. So where are our negative sections, right? Our negative sections are from -infinity to -2, union from 1 to 3, right? So those are our intervals where h is decreasing, right? Why? Because h prime of x is less than 0. Okay. Now, for our maximums and our minimums, this is where we're going to have to go way back up here to these two rules. Okay, when was it a maximum? It was a maximum when our derivative was 0, and what else? When it went from increasing to decreasing, right? Our original graph went from increasing to decreasing, and then our slope was 0. That was a max. So let's look for that. So now, though, we want to see where is h prime of x 0, and where does it change from increasing to decreasing. So first let's look for these 0 points, okay? So the 0 points are going to happen at -2, at +1, and at +3. Those are all h prime of x equal to 0. But to get a maximum, what did we say? We said we wanted it to change from increasing to decreasing. So here we want it essentially, what does that mean? We want h prime of x to be positive and then change to negative. So that only happens 1 point. Where does it change from positive to negative? Happens at 1. So we're going to say that x equals 1 is a relative maximum because two things. Because h prime of x equals 0, and h of x changed from increasing to decreasing. Okay. So it's a little bit tricky. Okay. And so our next one is going to be very similar, but it's going to be the other 2 points. So it's going to be x equals -2 and +3 are our relative minimums. Why? Because two things. First, because h prime of x was 0. But then secondly, what happened is this was decreasing, right? Our green was decreasing. Now, why is it decreasing even though the graph is going up? It's decreasing because the slope is less than 0. right? And this is the graph of the slope. So when we have a negative slope, right, back from math 1, like a negative slope, our graph is decreasing. So we don't care that this green line is going up because it's not our graph of h, it's our graph of the slope. So what happened? H of x changed from a decreasing slope to an increasing slope at those points, right? We were below the axis here, and then we came up above the axis. We were below the axis, decreasing. We came above the axis. We went from decreasing to increasing. Okay, I know this is tricky. We're going to do a lot of practice with it. Okay, so our very last thing would be our tangent lines and our secant lines. So if h of -1 was 1/2, what is the equation of our tangent line? So I'm going to say our x1 is -1, right? There's our x1. Our y1 is 1/2, right? Because h of -1. And to get our slope, how do we get our slope? We take our x1, our -1, and we plug it into the derivative, right? This is always the original, like f of x or h of x. This is always the derivative, f prime of x or h prime of x. So how would I find h prime of -1? How would we find that? Well, we would have to look on our graph. So on our graph, I'm going to go ahead and kind of clean this up a little bit. H prime of -1 is there. So this is not an x1 and a y1. Be careful. When we see -1, 5, because we're on the graph of h prime of x graph, this is saying that when x1 is -1, h prime of -1 is 5. That's what that's saying. So our m is going to be 5. So our equation would be y minus 1/2 equals 5 times x minus -1 or x plus 1. Now let's do the same thing, but this time they're asking for a normal line. So same setup, x1 we're going to put as 2, y1 we're going to put as -3 because this is for the h, right? For the h, for the original. And for the m, we're going to look on our graph because we have h prime of x. And at 2, our slope is -2. Okay, but I don't want this, I want the perpendicular slope. Why do I want the perpendicular slope? Because it's a normal line. So I want positive 1/2. We're going to flip the sign and change the value. So y plus 3 equals 1/2 times x minus 2. So always be careful about normal lines that we don't want the slope, but we want the perpendicular slope. Okay? So I know this is a little bit much, especially this last section looking at with the graph, but we will spend a lot of time on this, and we're going to work on it all day in class tomorrow.